Hi everybody, this is the second lecture PowerPoint or presentation for chemistry. And in this presentation, we're going to discuss chemical bonds. And so chemical bonds are the way we make molecules from atoms of elements. So things like sodium chloride, which is what's depicted here, is the joining of an atom of sodium plus an atom of chlorine to form sodium chloride. So we're going to talk about the different types of chemical bonds and what their different examples of each of those types. So when we see a formula such as this one here, that's a molecule. And so it's made up of a bunch of atoms. And so this is glucose. So that's the chemical formula for glucose. And what this means is that one molecule of glucose has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And there is a specific order, but that's more a chemistry kind of topic, so we're not going to talk about that. So when you see something like H2O, that means a molecule of water is made up of 2 hydrogens and 1 oxygen. So that ratio is important. You can't change it. If you have more than 1 molecule of water, it would be 2 H2Os. And likewise, if you had 2 glucoses, it would be 2 C6H12O6. So you can't change the subscripts here because that's what constitutes what the molecule is. So for example, if you had H2O2, that is not water. It's a different ratio of hydrogen and oxygen atoms. That's actually hydrogen peroxide. I always tell a joke here, but I don't know if I should tell the joke now. So if 2 Bio 156 students walk into a bar and the one says to the bartender, "I'm really thirsty, I'll have a nice cold glass of H2O." And so he gets it. And then the second student said, "That sounds really good. I'll have H2O too." And he gets that and drinks it and he dies, because that was hydrogen peroxide, not water. It doesn't go as good, the jokes online. But anyway, so that's what a molecule is. And so a molecule is formed by bonding between atoms. They can be more than one of the same atom. So example, the oxygen that we're breathing in the air is O2. It's 2 atoms of oxygen bound together. Or it can be different atoms like hydrogen and oxygen in water. And bonding is done between electrons in those outermost shells. So remember when we drew the configurations, and oxygen, for example, has 6 electrons. So 2 are in the first energy level and 4 are in the second. It has 8. I said 6. Excuse me. 2, 4, 6 in the second energy level. And it's those electrons in the outermost energy level that are involved in forming chemical bonds. And so that's what we're going to talk about a little bit more. Now, when atoms come together and form bonds and form molecules, the molecule, or the substance that's formed, is different in terms of chemical characteristics than the original elements for. For example, if we go back to sodium chloride as an example, so you have an atom of sodium and an atom of chlorine. So sodium is a metal. It's very explosive. It doesn't actually occur as pure sodium because it's so reactive. So you don't like go hiking and find a hunk of sodium lying on the ground. It always would react with water or even sometimes air. So it's kind of a very reactive metal. Then you have chlorine, which is a poisonous gas. But when we combine them, we form good old table salt that is not an explosive metal or a poisonous gas. So the compound that's formed from the combination of those two elements, it has completely separate characteristics than the original elements do. So we're going to talk about the two primary types of bonds that occur in forming molecules or compounds. Those words have slightly different meanings in chemistry, but I will tend to use them interchangeably. The first time we're going to talk about are ionic bonds. And ionic bonds formed when electrons are transferred from one atom to another atom. Remember how we said that atoms have electrons in different energy shells? Sodium, for example, atomic number is 11. So it has, if you look at an atom of sodium, the first energy level can only hold 2 electrons. So that leaves 9 electrons for sodium. So then you go to the second energy level. The second energy level can only hold 8 electrons. So that's a total of 10. I'm going to show you this again. So there's 1 electron out all by itself in that third energy level. Atoms are more stable. That is, they want to have their outermost energy level full. So if it's second, third, that would be 8 electrons. If it's only the first, it would be 2. And so if it has an unfilled outer shell, it will form bonds to try to get a filled outer shell. So if sodium can get rid of that 1 electron, it will have 2 energy shells and they'll both be full. So that makes it more stable. So sodium will participate in reactions where it can get rid of that outermost electron. So as I said, sodium has only 1 electron in its outermost shell. Chlorine, the other atom or element in sodium chloride, has 7 electrons in its outermost shell. So if it could get one more, then it would have 8 and it would be happy. Not really happy, but more stable. So sodium and chloride, when they form a bond, what happens is that the sodium actually gives an electron to chlorine. So sodium loses an electron. That means it no longer has the same number of protons and electrons. It has given away an electron, so it now has 11 protons, but only 10 electrons. And since they're charged, it actually has a positive charge. And an atom with a charge is called an ion. So sodium becomes a positive ion. So that, again, has different chemical characteristics than the sodium atom of the element. Chlorine, on the other hand, takes that electron from sodium, and so it gains an electron. So chlorine, the atomic number is 17, so it has 17 protons, but it now gained an electron, so it has 18 electrons. And so it is an ion with a negative charge. And what holds sodium and chlorine together in a salt crystal is the attraction of those opposite charges. So it's kind of like they're held together like a magnet. And so this is just, I'm not sure. This is actually a little animation, but it doesn't look like it's going to work.
Sometimes atoms complete their outer shells by stealing or giving away electrons. This happens between sodium and chlorine atoms. An electron moves from the sodium atom to the chlorine atom. The outer shells of both atoms are now complete, containing 8 electrons. The chlorine atom now has 18 electrons but only 17 protons. Because an electron has a negative charge, the chlorine atom now has a net negative charge. Such a charged atom or molecule is called an ion, in this case, a negative ion. The sodium atom has lost an electron, leaving it with an extra proton, which has a positive charge. The sodium atom has become a positive ion. Ions with opposite charges are attracted to each other, forming an ionic bond. These ions combine to form a compound with new properties. In this case, sodium chloride, ordinary table salt, is formed.
So that's an ionic bond. An ionic bond is formed between ions that have either gained or lost electrons. And so again, the sodium loses an electron, which goes, sorry, I can't seem to get that slide to come back up again. So it was just showing you again, the sodium loses an electron, the atom of sodium, it becomes an ion. Chlorine gains an electron, and it becomes an ion. And both of those are now more stable because they have filled outer shells of electrons. And so that's how an ionic bond is formed. It's when an atom either gains or loses electrons, and it's attracted to another atom that has gained or lost electrons. And so those are important, and many types of molecules are formed by ionic bonds. We're going to talk next about another type of bond that is actually really important in living cells, because many of the important molecules that are needed for life are formed by this type of bond, and it's called a covalent bond. So a covalent bond is a little bit different than ionic bond, because in an ionic bond, the electrons actually leave one atom and go to another atom. In this case, the atoms aren't kind of strong enough in terms of their ability to pull an electron away. But these atoms still want to have that filled outer shell of electrons. So what they do is they share their electrons. So the important difference between an ionic and a covalent is that in covalent, the electrons are not transferred, but they are shared. And so what holds them together, the atoms, are the sharing of electrons. So if they share one pair of electrons, that's called a single bond. They can even share more than one pair of electrons and form a double or triple bond. And so I'll give you some examples of that. This is another little video. Let me see. You should be able to watch these also.
A covalent bond is the sharing of a pair of outer shell electrons by two atoms. For example, each of these hydrogen atoms has one electron in its outer shell, but needs two electrons to complete its outer shell. If the two hydrogen atoms share electrons, they can both complete their outer shells. The shared pair of electrons constitutes a covalent bond, shown in shorthand as a line. The covalently bonded hydrogen atoms form a molecule of hydrogen gas. A molecule is defined as two or more atoms held together by covalent bonds. An oxygen atom needs two electrons to complete its outer shell. Two oxygen atoms can share two pairs of electrons. A molecule of oxygen gas is held together by a double covalent bond, two shared pairs of electrons. A carbon atom needs four electrons to complete its outer shell. It can share electrons with four hydrogen atoms, forming a methane molecule containing four single covalent bonds. Methane is a compound, a substance formed by the combination of two or more elements. We call methane natural gas. It is the fuel burned in gas stoves and furnaces. An oxygen atom needs two additional electrons to fill its outer shell. Thus it can form two single covalent bonds. An oxygen atom can share electrons with two hydrogen atoms, forming a molecule of water containing two single covalent bonds.
So those are some examples of excuse me, common covalently covalently bound molecules. I'm going to talk a little bit more about them. So when you have a molecule that's formed by covalent bonding, usually, and for some reason it's not showing up well, the dash is indicating a covalent bond. So hydrogen gas is H2. It's 2 atoms of hydrogen. And remember, hydrogen just has 1 electron. First energy level needs 2 to be full. So when they share their 1 electrons, they kind of each have 2. And you would indicate that with a dash, and that means 1 covalent bond. Oxygen, which is the oxygen that we breathe in the air, oxygen doesn't really exist as just O because it's not stable. Those atoms want to have a filled outer shell. So what it does is it shares 2 electrons with another oxygen atom to give them a total. So that gives each of them 8 electrons in their outer shell. That's much more stable. And so that would be indicated by a double dash because they're sharing 2 pairs of electrons. So all the oxygen you're breathing right now is O2. It's not just O. And then carbon we're going to talk a lot about because it's the backbone of many of our biologically important molecules. And carbon has 4 electrons in its outer shell. So it can form 4 covalent bonds, and it can even form covalent bonds to another carbon. So you can get like a chain of carbons. And so we're going to be talking about carbon quite a bit. So covalent bonds have kind of 2 subcategories. And that's called nonpolar and polar covalent bonds, because in covalent bonds, as we just talked about, the atoms are sharing electrons. And sometimes they don't share them equally. And other times the atoms are sharing them equally. And by sharing equally, it means that the electron is kind of right in the middle between the 2 atoms. So if they are in the middle and are being shared equally, it's called a nonpolar covalent bond. So in oxygen, because the 2 atoms are the same, they're equally sharing. So oxygen, O2, is a nonpolar covalent molecule. However, sometimes the electrons are not shared equally, and that's because some atoms will have a stronger pull on the electrons, and when the electrons in the covalent bond are not shared equally, it's called a polar covalent bond. And that's because the electrons are closer to one atom than another atom. And that gives kind of a partial charge. The best example of this is water. And our next lecture is just going to be about water. And we have a lab that we'll be doing that's mostly about water. So water is 2 hydrogens and 1 oxygen. So oxygen has 8 electrons and 8 protons, and hydrogen has just 1 proton and 1 electron. So if you think of this sharing of the electron, so hydrogen is going to share its electron with oxygen. And what holds an electron in to spin around the nucleus of an atom is the pull of the protons, because that's a positive charge. So we have this electron that's being shared. And there are 8 protons in oxygen pulling on the electron, only 1 proton in hydrogen pulling on the electron, which is kind of what's depicted here. So because oxygen has 8 protons, it's able to pull the electron closer to the oxygen atom than the hydrogen is. So it's not being equally shared. So the electrons are closer to oxygen. So oxygen is a little bit negative, hydrogen is a little bit positive. And here they're showing this electron here is closer to the oxygen than it is to the hydrogen. And so this unequal sharing of electrons is called a polar covalent bond. And that's very important in the characteristics of water that make it work to support life on Earth. And so we're going to be talking about that in the chemistry, the third chemistry PowerPoint. Bye-bye.